Good morning, Year 8. Welcome to the third lesson on our latest topic, which is all about America and the water issues surrounding America. Our title for today's lesson is Damming the Colorado River. If you want to get that jotted down, Damming the Colorado River, and let's get started. Little do it now for you. I need you just to write A, B, C, D, and E in your books, and I just need you to write down and label what the names of the things that we can see here are. So what's the name of the big river that runs right down through the heart of America? What's this ocean? What's this state here? Okay, so this should be in your books or in your work from last few lessons ago. What's this ocean here? And then what's this mountain range here? Okay, maybe it goes a bit further than I've demonstrated there. Pause and get that done, please. So we've changed pen colour. We're now doing some self-assessment. Give yourself a tick if you've got it right. So this is the Mississippi River. Okay, this ocean on this side is the Pacific Ocean, and it connects. If you go all the way across it, you get to Asia. We've then got California, or the Sunshine State down here, which is economically one of the most important states in America. Okay, it's also where all the tech is based. It's also where Hollywood is. Really important, really cool state. So that was California. We then got the Atlantic Ocean here. If you travel across the Atlantic Ocean, eventually you'll reach us. And then we have the Appalachian Mountains here. Okay, so a really important sort of mountain range for America. So let's make sure we've got them right, and let's get ready to move on. What we're looking at today is we're looking at damming, we're looking at managing rivers, we're looking at the impact that this can have. If you've got the reading, okay, it's up on the system, you can print it off. If not, don't worry, it's on the screen, so we can go as we follow along as we go. Okay, and we're looking in particular at the Colorado River because it has probably America's most famous dam on it, and that's what we're going to look at. And that's what we're going to sort of use as our sort of hinge, our focus for introducing the wider issues of damming rivers. Okay, and I'll talk a bit more about damming rivers in a second, but let's get started by finding out a bit about the Colorado River. So the Colorado River basin, situated in North America, lies in the southwest of the USA. So up here you've got a picture of America, and as we can see, it's just down there. This is California here. Okay, so if you look back at the map in your book that you drew or you worked on last time, that's where you can see it. Right, that gives me a rough idea of where we're looking. The river is approximately 1,450 miles long. Its sources are in Wyoming and Colorado, and where it flows southwest through Utah. Sources are in Wyoming and Colorado, from where it flows southwest through Utah, Nevada, Arizona, New Mexico, California, and Mexico before entering the Gulf of California. The Colorado River drainage basin covers 64,000 kilometers of North America. The Colorado River is joined by 25 large tributaries. So remember, tributary is a smaller river joining the bigger river. Okay, that idea of tribute, okay, it works towards it, of which the Green River is the largest by length and discharge. Much of the river basin is very arid. Okay, arid means dry. The upper basin, okay, so this part around here that I'm drawing on now, maybe a bit higher. Upper basin is characterized by high elevations, so it's rocky, narrow valleys, which we'll see some pictures of later, and a short growing season. Okay, it's not ideal for growing crops. The lower basin, so when we get down to this stage around here, it has wide basin, so it's a wide river, okay, and it has a longer growing season. But obviously, to get the water down here, you need to have the water up here where it's arid and it's dry. So a couple of important things to consider when we look at the climate. Okay, there is a north-south divide. Okay, in terms of temperature and rainfall. Much of the lower basin experiences very high temperatures of 40 degrees or more. Okay, so we think about Arizona. This little bit here is all very much like a desert. Okay, Colorado is very mountainous. Okay, we've got the Rocky Mountains, okay, that we looked at in the very first lesson of this topic, come all the way down here. Colorado is a really cool place, really trendy place to go skiing. And obviously, to go skiing, you need snow. You need snow. You need some sort of precipitation, some sort of rainfall. Obviously, it's not rain; it's snow. Months of extremely high summer temperatures in much of the basin leads to excessively high rates of evaporation. So in the summer, it gets hot up here as well. The whole basin gets hot in the summer, which means lots of the water evaporates. Okay, it's not used by animals or humans. Okay, it actually just evaporates straight from the river. The river flows in a largely desert region, where much receiving less than 250 millimeters of rainfall per annum. So all this lower bit down here that I've talked about, okay, doesn't get much rain. It needs the rain to come from up the river. Rainfall is seasonal with thunderstorms and flash flooding a possibility. So when it does rain, it's very seasonal. It doesn't happen consistently, it happens in short bursts. Okay, and that's going to be important when we look at next, which is all about damming. So let's just have a look at some key words and get them talked about. So what I'd like you to do is, in your pen, in your books, or your paper, or if you're typing this, it's fine. Can we type up the definitions for these two words? A dam. Okay, the dam is a barrier constructed to hold back water and raise its level, forming a reservoir used to generate electricity or as a water supply. So when you dam a river, you stop stuff moving down it. Okay, that means that behind the dam, you get a big backlog of water. And you can either use this for generating electricity or using the water as a supply. Often they do both. Okay. Secondly, we've got water resource management. This is the activity of planning, developing and distributing and managing the optimum use of water resources. So water resource management is sitting down and looking at a river and thinking, right, how can we best use this river? How can we get the most from this river? So write them two definitions down for me, please, and let's move on. Now let's take a minute to do a little bit of work to sort of capture what we've talked about so far. Firstly, I want you to describe the course of the Colorado River for me. When you think about the source or the sources, when you think about the length, when you think about the states it passes through, okay, and where the mouth of it is. Okay, so you're writing this quite as a descriptive piece. The Colorado River starts, or the source of the Colorado River is. It then passes, it travels. Okay, so try and include some detail in that description for me. Then I want you to explain why the climate is a problem for the Colorado River. So think about that word arid. Okay, think about how much rainfall there is, okay, and how that obviously that isn't very much in certain parts. So let's pause the video and get that done, please. So I mentioned a few slides ago of what a reservoir was. You've written a definition. It's this idea of capturing the water. And it said you can use it to generate electricity. But how? Okay, so what I've got here is just a couple of little images to show you. We'll start with the bottom one. So what we've got here is we've got the dam, which is made of concrete. It's a huge, big structure. It has to be really strong. And we'll look at a bit more detail about that in a second. And what you have is you have this little, what's called a sluice gate. Okay, and that lets water out when you choose to let it out. Okay, so you have all this water building up here in the storage reservoir. You then, just let some water out, and because you're funneling that water, it makes it really concentrated. Okay, and as it's going out, it goes past a generator. In simple terms, this generator spins round. Okay, and as it spins round, okay, what then happens is that generates electricity. It then sends it up to the transformer, and then it sends it to the power cables. So this water here ultimately creates electricities that allow you to watch Netflix. Okay, the water then carries on and it goes back into the river. How does that look in real life? Well, this bit here is us sort of seeing this. So this bit is this bit. Okay, so it's been pumped through the other side, which we can't see, and it's come past the turbine where it's made the turbine spin. Okay, and now it's just being let go, and it just flows into the river channel here, and it goes down river. Now, importantly, okay, and this will become important later, we can see some silt here. Okay, so if you look at the diagram, some silt. That's going to become really important because that's a big problem. Okay, so that's how it works in short. So we've looked at some of the issues with the Colorado River. I've told you what a dam can do. It has been dammed, but let's just talk about what some of the advantages of the dam are. There is low annual precipitation, an unreliable rainfall pattern, and significant seasonal imbalance on the Colorado River basin. The north of the basin receives significantly more precipitation than the south, so the north gets all the water. There's a possibility of transferring water from an area with water surplus, so too much water, to an area of deficit by means of an aqueduct, canal or river. This will provide a regular, reliable water source for expanding urban areas, industry and agriculture. So what you can do is if you can control the river, okay, you can kind of move the water around so it's captured. So you can take the way you've got too much water in the north or the top, and then you can move it down to the south and you can use it either for agriculture or people's sort of domestic use, flushing your toilet. Sudden increases of river flow from seasonal precipitation or snow melting can bring a chance of flooding. Dams can be used to contain and regulate this flow. So you don't want all the water coming at once because that can cause flooding, so a dam can control that. There is irrigation potential for farming in areas such as Arizona. So if we can control the amount of water we've got, we can irrigate, which means you can sort of dig canals and you can use water quite effectively. with a ready market and easy transportation. Arizona's a huge growing city, so there's people who want to buy fruit and veg there. So if you can grow it there, you can sell it there easily. Hydroelectric power can come from the dams, such as the Hoover and Powell dams. Okay, so we've just talked about hydroelectric. This will generate power for industry, farms, and communities. So Las Vegas, all them bright lights, all them casinos, it's fueled by a dam. Like that last slide we looked at, that's how it's powered. This will provide jobs, stimulate the local economy. The area has geology suitable for the construction and storage of water, which makes it even more possible. We'll talk about that geology in a second. Finally, this will improve the navigation potential. So if you've controlled the river, you can move around the river, you can send goods up the river or down the river, i.e. you can use it as a form of transport. Okay? Dams can't be built anywhere. Okay, you can't just stick one, we'll stick one on that bit of the river. You need to think really carefully about where they're built. So let's go. Dams are enormous constructions, so solid foundations are needed to manage the heavy load from the concrete dams and the volume of stored water. The fact that you're building so much water, or you're storing so much water, means you're dealing with a huge, really heavy weight. Okay, so you need it to be strong. This means weaker sedimentary rocks are avoided due to the risk of structural failure. Harder rocks, like granites, are preferred. You need hard rock so it doesn't break. If you use weak sedimentary rocks, it could crumble, and then the last thing you want is that dam crumbling or anything around that dam crumbling, because it will cause all sorts of chaos. Loss of water through seepage needs to be considered. Impermeable and non-porous rocks are favoured to reduce seepage. So you want rock that's hard, okay, and non-porous. If it's porous, the water goes through it. That's not what you want. Okay, you want the water just to sit on top of it. Okay, if it goes through, you're going to lose that water, and you're losing the benefit of the dam. There are many sedimentary rock along the course of the Colorado, so in some locations, concrete has been used to line the valley sides. So they pumped concrete into the sides of the natural valley to make it better for humans. Obviously, that has huge environmental impacts for the animals and the other things that sort of used to live there. Dams must be built on geologically stable land with little risk of earthquakes. Okay, so you need it to be you can't have earthquakes underground. If you have an earthquake underground, the dam might break, and again, all that water, all that energy, all that power will be released, and that will cause chaos, and it will cause death and destruction. There is need for narrow cross-section, as this reduces the dam length and therefore building costs. A large, deep valley behind the dam is also necessary and means a greater volume of water can be stored for use. So if we look here, okay, this little diagram we've got here, this is now all water, okay, the bit I'm sort of colouring in yellow in a minute, and this is space. We have a small amount of water here, okay, but we've built a dam across this narrow sort of bit in the rock. We picked the narrow bit because it's cheaper. Okay, if it's cheaper, obviously that's going to save you money, but also you need it to be nice and deep running backwards so the water can build up. Okay, so this is a very blessed area because it can build up and you can keep it there. Okay, so there's some of the things that you need for a dam to be built. You can't just stick one on any river. You need to think carefully about the geography for the different reasons. So I've just talked about the conditions required to build a dam. Now I want you to think about it yourself and get it written down. When considering where to build a dam, people must consider. So aim for 2 or 3 ideas. Oh gosh, it's not very easy to write with this mouse. Okay, so aim for 2 or 3 ideas. So so pause the video and get that done for me. As we've seen, dams can be brilliant. They can create jobs. They can create a reliable water source to make sure that you can farm effectively. They can create cheap electricity, but they have negatives. The Hoover Dam has made a significant impact on the lives of the people in the southwest of America, and it has also affected the environment of that region. Okay, so it's changed the environment, okay, around the southwest of America. The most affected aspect of the Colorado River due to the Hoover Dam is the lack of nutrients and silt downstream. Okay, so the lack of nutrients and silt downstream. Prior to the 1930s, before the Hoover Dam was built, the Colorado River carried approximately 125 million tons of suspended sediment to its delta at the head of the Gulf of California. So it carried 125 million tons of mud, nutrients, biodegrading animals, all these different things were carried as sediment down the river. And when the river went round meanders, bits of it were dropped off. Okay? Animals and things ate the sediment or fed off the sediment. The sediment was a real benefit for the river. It needed it. Now, if we think about it, I showed you on that picture before. The sediment was trapped at the bottom of the dam and it's not going down the river, which means the nutrients aren't going down the river. Which means if I'm using that water, it's not got all the things that I used to get from that water, which means it lacks sort of the power that it used to have. The communities downriver are being starved of water. At present, the Colorado River does not discharge either sediment or water to the Gulf. That's really important. Okay, there's not enough water coming through, so not enough water makes it all the way through to Mexico and through that Gulf. The sediment isn't going either, which means that the benefits can't be felt. The communities downriver are being starved of water and sediment. Sediments are organic or material matter that are major contributors to the complex nature of nutrient cycling in a body of water. So they're part of the food cycle, okay? And they keep all the good things going around, and it's really important. If they're stopped, that cycle doesn't happen, okay? And then that water cycle suffers. Animals and plants have grown accustomed to the flooding of the Colorado, and when the Hoover Dam eliminated natural floods, it caused a decrease in the native fish downstream of the dam. So the animals that used to know, right, this is going to dam there, natural cycles were built from it, okay? They no longer get that flooding, which means that their lives are impacted. Fish, okay, can no longer use the river as well, and therefore there's been a decrease in the types of fish that are there. They've combated this by putting some new species, but they're not the native species. Now, this bit of information isn't but just talking more widely about dams in general. Dams destroy, demolish, and devastate the environment. Negative environmental impacts of dams can occur upstream, downstream, and in reservoirs. So everywhere can be affected by a dam. In addition to habitat degradation, i.e. destroying habitats, degradation is destroying. Dams induce a significant barrier effect by blocking the downstream flow of sediment and nutrients and preventing the migration of fish and other aquatic organisms. Okay, aquatic organisms, animal life. The ecosystems are unbalanced by these changes. So the ecosystems, okay, that are delicate balance are disrupted. Okay, the food chain, the food web is disrupted by dams. Human health and welfare can also be affected. When a dam disrupts the natural flow, for example, the river downstream decreases in water levels, fish and sediment. That can affect farmers, can affect fishermen, can affect people who use that river. These factors threaten the lives and jobs of people living downstream. However, the most significant impact of dams on people's lives has to do with displacement. So this is talking generally about dams, so dams in Asia, Africa and Europe and America. Dams worldwide have displaced, moved an estimated 40 to 80 million people. This means people have had to move from their present home to find a new home or to create a new livelihood. Dams also destroy cultural landmarks such as buildings, shrines, burial grounds and sacred landscapes by submerging them in water. Not only do dams ruin the lives and cultural identities of millions of people, but they also create health hazards. While dams provide easy to access water, they create conditions for disease carrying mosquitoes and snails, which can bring illnesses such as malaria. Okay, this type of environment is clearly hazardous living near dams. So that, again, this is more so to do with Asia, okay, and Africa, not so much to do with America. But one of the problems with dams is you create a big body of water, and that allows mosquitoes to move there. Now, what I want you to do is to explain 2 disadvantages of dam building. Okay, so you're looking for 2 here in your books. Let's get that done. So pause the video and get that done, please. And finally, what I want us to do is you're following the email from your teacher, you're logging onto forms, you've got the 8 mini questions that are up there, and then 3 longer questions. We're looking for these to be longer to show off your knowledge. Again, so you've done this in your book, so you're just typing it up, okay? Outline the course of the Colorado River. Again, try and get that precise detail in there. Get into these good habits of using precise geographic language. The source, the mouth, okay? Tributaries. An advantage of building dams is, this means that, and a disadvantage, okay? So when I say try and explain it. Cheap electricity, this means, okay? If you've got cheap electricity, what's that mean for your business? Okay, what's that mean for your profits? What's that mean for your standard of living? So try and explain, try and keep thinking this means that, this means that, this is good because. And again, the same for a disadvantage. That's what I want you to do for this lesson. Let's get that done. Well done, guys. Thank you.